Okay. So like I said, we're looking at multiplying complex numbers. This really isn't too bad. I mean, especially if you're okay with multiplying polynomials, if you remember how to do the box method, I mean, you're really not going to have too many issues. There is one thing that is very important for complex numbers. By definition, I squared equals -1. So anytime you get an I squared, you want to simplify it into like a real number. And what I tell myself, I'm going to say this a lot during the notes, is when you have an I squared, your I squared goes away, and you switch your sign. And we'll see. Like I said, I'm going to say this a lot, and we'll see what I mean by this. But anytime you have an I squared, basically it's going to go away, but it's going to switch your sign of what you had there. Because basically, if you replace it with a -1, if you multiply a number by -1, well, it just stays the same, but your sign switches. Like 5 times -1 is -5. -5 times -1 would be +5. So um, that's basically what's going to happen. If you want to look at this first example, you can see they distribute. If you have a monomial, like one thing times a binomial, you just distribute. And notice when they distribute this, -3i times 4i, you get -12i squared. So like I said, the I squared goes away and it switches your sign. Or basically you could also just, you could also replace your I squared with a -1. Like so, but as you can see, this turns into +12. The I squared goes away and it switches your sign. And then you can see they distribute the next part and they get 12 and 15i. So that would be your final answer for a question like that. But let's just jump into a few examples. But I mean, feel free to look at this worked out example they gave you closer if you'd like. But you're going to see some problems where you just got to distribute, and then we're going to see some problems where you have to use the box method. I'm pretty sure, if I'm not mistaken, I think pretty much all the problems in the Delta Math section are the box method. I think it might be all of them. I'm not 100% sure, but most of them, when I was like working them out to just kind of make sure the section was okay, I think I only had box method. So you might not actually have any examples like 1 through 4 on your Delta Math, but I still want to show you these kind of problems in case you come across something like this. So like number 1, you would just distribute your 5. So I mean, you would just multiply 5 times 3 is 15. 5 times -2i would just be -10i. You don't have any I squareds or anything like that, so you are good to go. That would be your answer. And if you remember, your answer should be in this order: a plus bi, like your real number part first, then your imaginary part. If I remember though, the last Delta Math section, I saw some students were like putting in their answer like reversed, and it didn't mark you wrong. So it might not be that big of a deal. But you could, like in the future, you could have, like if you're doing this in college, you have a professor, they'll probably be a little bit picky. They'll probably want to make sure your answer is in this correct order. So let's look at number 2 though. If you distribute this one, you would get 16i plus 10i squared, because I times I is I squared. You have 2 i's. So this isn't our final answer though, because anytime you get an I squared, you want to simplify it. So remember, if you have an I squared, it goes away and it switches your sign. So this would be 16i, and then that plus would turn into a minus, and your I squared would go away. Because really what you're doing, really what you're doing is you're replacing this I squared with a -1. 10 times -1 would be -10. But you don't need to write that if you understand what I say. The I squared goes away, switches your sign. And technically, like I said, your answer should be, like, you should have your real number part first. So you'd want to switch this around: -10 plus 16i. But I'm pretty sure Delta Math would take either one of these answers from what I've seen. But if it is marking you wrong, it might be the order you have it in. But kind of look at if you do miss one, make sure you look at what the answer is, just to see, oh, did you just have it the wrong order, or if there's a bigger issue you might have had. So let's look at a couple more of these. So you just distribute, you would get -32 -4 times -5 would be positive 20i squared. So like I said, your I squared, oh wait, what am I doing? That wouldn't be I squared. Sorry about that. It's just -4 times -5, so it would just be 20i. So we don't have an I squared, so actually ignore what I was saying there, sorry. That would just be our answer, because we didn't have I times I. But in number 4, we'll have -3i times -6 would be positive 18i. I'm just going to write it. Actually, I don't want to write it down. So I'll just see if I can see here. I'm going to use a different color just so. So you'd have 18i, and then -3 times -7 would be 20 plus 21i squared, which remember, your I squared goes away, switches your sign. So that would be 18i minus 21. And like I said, technically your answer should be like in the reverse order, your number part first, then your I part. But to be honest with you, I'm pretty sure Delta Math will take either answer. I know in the last comp, like when we were doing the add and subtracting, it took it either order. I'm not 100% if it's pickier on the multiplying. I can't imagine it would be though. So if you get a problem like this where you just got to distribute, that's kind of the idea. But the next set of problems I want to look at are where you're going to have to use the box method. So if you have a binomial times a binomial, basically two things times two things, usually you put your first one along the top and your second one along the side. And then you just multiply, like 7 times 5 would be 35. 7 times 2i would be 14i. 12i times 5 would be 60i. And then 12i times 2i would be 24i squared. But anytime you get this I squared, so it's pretty much always going to be this bottom right box, unless your numbers aren't in the proper form. But remember, your I squared goes away, switches your sign. So 24i squared would actually be -24. Then you're just going to combine your like terms. So you can combine these two boxes. So 35 plus -24 would be positive 11. And then you can combine this diagonal, like your I part. So 60i plus 14i would be 74i. If you don't like the box method, if you've learned to FOIL, like if you know what I mean by the FOIL method, you could also use that. You don't have to draw a box and do the box method. So if you've seen the FOIL method in algebra, one of your algebra 2 classes or algebra 1, and you remember how to do that method, that's totally fine. I'm going to demonstrate the box method because I think that's how most people probably have seen these types of problems before. So it's probably the most comfortable for most students, I would guess. But like I said, if you don't want to use the box method and you know another way to do these, feel more than free to do that. So I just wanted to look at a few examples. Like I said, especially when you're working on your Delta Math, you're going to want to probably have a little piece of scrap paper so you can draw your boxes. Usually I put the first one along the top, like your first binomial, and then your second binomial along the side. And then just multiply it out. 7 times 3 would be 21. 7 times 4i would be 28i. 8i times 3 would be 24i. And then this last box, 8 times 4 is 32, and then I times I would be I squared. But remember, I squared goes away, switches your sign, so that would turn into a -32. And then just combine like terms. So you would have 21 and -32. That would, if you add that like in a calculator or mentally, you should get -11. And then add your I diagonal, 28 plus 24 you should get 52i, right? Yep. And then that's your answer. How about I do one more, and then maybe I'll have you try number 7. So 8 minus 3i, I'll put along the top. 4 plus 5i, I'll put along the side. Multiply this out, 32, -12i, 40i. 5 times -3 would be -15i squared. Remember, I squared goes away, switch your sign, so that would turn into a positive 15. And then just combine your diagonals. So 32 and 15 would be 47. And then do your I diagonal. Negative 12 plus 40, that should be positive 28. So how about you guys try number 7? So if it helps just to kind of see what it's going to look like, I mean, this would be your box. And keep in mind, that's really like one I. If you want to put the one, you can. Let's see if you can fill out your box, get your answer. I'll give you guys a little bit to try that. All right, so if you did try this one, I mean, 3 times 2 would be 6. 3 times negative 1i would be negative 3i. 5i times 2 would be 10i. And then 5 times negative 1i would be negative 5i squared. So remember the I squared goes away, switches your sign. So then just combine like terms. 6 plus 5 would be 11. 10i plus negative 3i would be 7i. And those are your final answers once you add what's inside your box. If you do see a question like number 8 where you have a binomial squared, remember that's really 8. Like really what that means is that's 8 minus 2i times 8 minus 2i. So basically you're gonna, if you're using the box method at least, you're gonna just, let's try that one more time. You're gonna put the same thing along the top and the side. And then just do it the same way. So I'll do this one a little bit quickly just so you guys maybe can get started on your delta math. But that would be 8 times 8. 8 times negative 2 would be negative 16i. Negative 2 times 8 would also be negative 16i. And then negative 2 times negative 2 is positive 4. I times I is I squared. So you switch your sign and the I goes away. And if you can do that step in your head, if you're like, oh, I got 4i squared, but that would be negative 4, you don't need to write it out, if that makes sense. But if you combine 64 and negative 4, that would be 60. And then negative 16 plus negative 16 would be minus 32i. If you look at the blank notes, I'm not going to do all these examples just because I think it's a little bit much if you're getting it. I'd rather you guys get into the delta math and try some of these, but I will, when I upload my key, I will upload like these worked out if it's helpful to have more problems to look at. So that's it for our notes today, but this in delta math, it's going to be more like these bottom examples. You're going to want to use that box method. So let me stop.